Welcome to Ask and Learn.
Now, problem number 127. Air flows steadily through an isentropic nozzle. The pressure, temperature, and velocity of air at the nozzle exit are to be determined. Firstly, we will draw a simple type of nozzle to understand our question. T2, P2, V2. Air enters here, and the inlet conditions are 35 degrees centigrade, temperature 200 kilopascal, pressure, and 50% relative humidity. We will take the usual three assumptions. This is a steady flow process, and thus the mass flow rate of dry air remains constant during the entire process. So m dot a1 is equal to m dot a2 is equal to m dot a. Second assumption, dry air and water vapors are ideal gases. Third assumption, kinetic and potential energy changes are negligible. So, the inlet state of the air is completely specified and total pressure is 200 kilopascal. The properties of the air at the inlet state may be determined from the psychometric charts. So, H1 is equal to 57.65 kilojoule per kilogram of dry air. Specific humidity is equal to at 1 is equal to specific humidity is equal to 2, which is 0.00880 kilogram of water per kilogram of dry air due to no condensation. After that, as its isentropic process, so S1 is equal to S2, which comes out 5.613 kilojoule per kilogram into Kelvin into dry air. Okay. After that, we assume that the relative humidity at the nozzle exit is 100%. Since there is no condensation in nozzle, other exit state properties can be determined from the psychometric chart, and the results are H2 is equal to 42.53 kilojoule per kilogram of dry air. P2 is equal to 168.2 kilopascal, and the temperature would be 20 degree. An energy balance on control volume gives the velocity at the exit. H1 is equal to H2 plus 1 plus specific humidity at exit over volume cube divided by 2. Putting the values, 57.65 is equal to 42.53 plus 1 plus 0.008803 into V2 divided by 2, and here by resolving the equation we will obtain 73.2 meter per second. This is the velocity of air at exit. Thank you.